In this video, we will talk about how to solve quadratic equations using the square root property. So the square root property says if you have some number x, and if x squared is equal to k, or k is greater than or equal to 0, then x must be equal to plus or minus the square root of k. So let's check out a few examples of how we can solve quadratic equations by using this property. So in this first example, we have x squared is equal to 25. We want to figure out what values of x make this expression true. So notice that we can apply the square root property here because it says if x squared is equal to k, then x is the plus or minus square root of k. So here we have x squared is equal to 25. So that means x must be equal to plus or minus the square root of 25. Now the square root of 25 is just 5. So we could write this as x is equal to plus or minus 5. So that's our final answer. Or if we want, we can write this as x is equal to 5 or x is equal to negative 5. So there are two possible answers for x. And what we'll find is that if we plug in either of these values, so if we plug in a 5 for this x in the original equation, 5 squared, that is 25. And if we plug in an x is equal to negative 5 squared is also 25 because negative 5 squared is just negative 5 times negative 5. And when you're multiplying two negatives, you end up with a positive result. So that's also equal to 25. So these are our two solutions on this one. X is 5 or x is negative 5. All right, let's try another example. Let's say we have 3x squared is equal to 12. We want to figure out what values of x make this expression true. So to get x all by itself, we can start by dividing both sides by 3. Because on the left-hand side, these 3's will cancel out and we'll just be left with x squared. On the right-hand side, we have 12 divided by 3, that's 4. So once again, we can use the square root property to figure out what values of x make this true. So applying the square root property, we can take the square root of each side. So on the left-hand side, we have the square root of x squared, that's just x, is equal to, on this right-hand side, we will have plus or minus the square root of 4. Now the square root of 4 is 2. So really we get x is equal to plus or minus 2. Or if we want to write it like this, x is equal to 2 or x is equal to negative 2. If you plug in either of these values into x for this original equation, you will get a true result. All right, let's try this one. X squared minus 32 is equal to 0. We want to figure out for what values of x make this true. Well, to get x by itself, we can start by adding a 32 to each side. On the left-hand side, these 32's cancel out. We're left with x squared is equal to 0 plus 32 is 32. Now again, we can apply the square root property where we take the square root of each side. So on the left-hand side, we get x is equal to plus or minus the square root of 32. Now the square root of 32 doesn't have an integer value, but we can still simplify the square root of 32 by recognizing that we can break it down into the square root of 16 times the square root of 2. Since 16 times 2 is equal to 32, now the square root of 16 is 4. So we can write x is equal to plus or minus 4 times the square root of 2. Or if we wanted to, we could also write it as x is equal to 4 times the square root of 2, or x is equal to negative 4 times the square root of 2. These will be our final two answers. All right, let's check out this example. We have x minus 4 squared is equal to 49. Now, to apply the square root property in this example, when we take the square root of each side, the square root of this expression raised to the power of 2 is just whatever is inside the parentheses right here. So we would just be left with x minus 4. And on the right-hand side, we would get plus or minus the square root of 49. Now, the square root of 49 is 7. So really we have x minus 4 is equal to plus or minus 7. So to solve for x, we can add a 4 to each side. So we get x is equal to 4 plus or minus 7. So there are two possible answers here again. We get x is equal to 4 plus 7 or x is equal to 4 minus 7. So for this first one, 4 plus 7, that's 11. So our first answer is x is equal to 11. On this one, we have x is equal to 4 minus 7, that's negative 3. So here are two possible solutions for x. All right, let's try this example. We have x squared plus 6x plus 9 is equal to 36. So we're trying to solve for x. So we'll notice on this left-hand side, we have a trinomial, 3 terms. So we can try to factor this trinomial. And the way that we do that is we ask ourselves, what numbers multiply to 9 and add to 6? Well, that would be 3 and 3. So we can write this as x plus 3 times x plus 3. That's how we can factor this original trinomial. And what we'll notice is that we have two x plus 3's. So really, this is the same as x plus 3 squared. So we have x plus 3 squared is equal to 36. And again, to solve for x, we can apply the square root property where we take the square root of each side. So when we take the square root of this side, we're just left with this expression that's inside the parentheses. So we're left with x plus 3 is equal to plus or minus the square root of 36. Now, the square root of 36 is just 6. So we really have x plus 3 is equal to plus or minus 6. So to get x all by itself, we can subtract a 3 from each side and we'll be left with x is equal to negative 3 plus or minus 6. So another way to write that is x is equal to negative 3 plus 6, or x is equal to negative 3 minus 6. So for this one, we get x is equal to negative 3 plus 6, that's 3. So that's one solution. And x is equal to negative 3 minus 6, that's negative 9. So x is equal to negative 9 is our second solution. And we'll find that if we plug in either of these values in for x in this equation, we will get a true result. All right, let's try one more example. We have 9x squared minus 8 is equal to 0. So we're trying to figure out for what values of x make this true. So to get x all by itself, we can start by adding an 8 to each side. So we'll get 9x squared is equal to 8. To get x by itself, we can divide both sides by 9. So we get x squared is equal to 8/9. Now again, we can apply the square root property where we take the square root of each side and we're left with x equal to plus or minus the square root of 8 over 9. Now when we have the square root of a fraction like this, so when we have the square root of some number a over some number b, we can simplify this by writing it as the square root of a over the square root of b. So for this example, we can write it as, let's write it up here, x is equal to plus or minus the square root of 8 over the square root of 9. Now the square root of 9 is 3, so really we can write this as x is equal to the plus or minus the square root of 8 over 3. Now we want to see if we can simplify the square root of 8 a little bit. So we could break down the square root of 8 into, let's write it right here, x is plus or minus the square root of 4 times the square root of 2, since 4 times 2 is 8, and that's all over 3. Now the square root of 4 is just 2. So really we get x is equal to plus or minus 2 times the square root of 2 over 3. So it's pretty ugly, but that is our solution. Or if we wanted to write it out separately, we could write x is equal to 2 times the square root of 2 over 3. That's one solution. And the other one is x is equal to negative 2 times the square root of 2 over 3. Those are our two solutions for x.